Hi, hello, welcome to another lesson of Secondary Math 2. So we're into Lesson 6. I hope you've enjoyed factoring back in the last unit. We're going to continue on with it. We're going to take it to the next step. So this lesson is an intro to solving quadratics and solving by factoring specifically. So during this lesson, you're going to learn how to find the output of a function if given the input value, and also be able to solve for quadratics by factoring any trinomial. All right, so solutions of functions. So every time we have a solution, we're always going to write it as a coordinate pair. So we talk about solutions as coordinate pairs. So that means I should have an x and a y coordinate to go with it. I like to think of this the address. Is where is that point on the graph? What's the address of it? When finding the solutions to a quadratic, we're finding the x-intercepts. So when we're looking for solutions, we're looking for our x-intercepts. Now I got some intel that question possibly could be on a quiz or a test, so make sure you have that one for our class. We can also find a solution if we're given a specific x value. So that's kind of that function notation happening. The solution would then be what the y value will be when x is at a specific value. So that's where we get that function notation. What's f at 3? We'd find that y value. So I have a couple different ways I can find solutions of a function. I can do it algebraically. I can plug in values for x. So this is when we're looking for that function notation, specific f of 3, f at 2. What is the y value when x is 3? What is the y value when x is 2? And then graphically, finding the y value will be for any given x. It's really simple when I'm doing graphically. It says use the graph to find f of 8. So remember this 8 right here, this is an x value. And I'm asking, what is the y value when x is 8? So I'm going to come over here on the graph. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to find where is it on the graph. So I'm going to go to where I hit the graph. It's right here, and that's at 6. So my answer is f at 8. It's going to be 6. Or if I write that as a coordinate point, I'd have 8, 6. Remember, I have my x, and I have a y. Okay, I want you to take a second, see where you can find it, this answer here. So remember, I have my negative 3. That's an x value. 1, 2, 3. We come up to where I hit it on the graph, right there at 10. So when x is negative 3 for this particular graph, y is 10. So as a coordinate point, I'd write that as negative 3, 10. Okay, so finding a solution algebraically, not crazy difficult. Evaluate f at 7, remember, so that's my x value. So what I'm going to do is anywhere in this equation I see an x, I'm going to replace it. So I'm going to highlight that. X is what I'm looking for. So I'm looking for f at 7. So I get 1/4. Oh, I came to that x. I'm going to replace it with a 7 minus 3 squared minus 5. Now this is just a calculator problem, or if you'd like to do this by hand, you totally can. Just remember your order of operations. So we do what's inside the parenthesis first. 7 minus 3 is 4 squared minus 5. Then I do my exponents. So 4 squared is 16, 1/4 times 16 minus 5. Then my multiplication, 1/4 is 16. That's the same as saying 16 divided by 4. So we get 4 there, minus 5 equals negative 1. So we know that f at 7 equals negative 1. If I write that as a coordinate pair, I'd say 7, negative 1. When x is 7, y will be negative 1 for this function. Okay, now you try, pause the video, get this written down, work on it, and then check the video for solutions. Okay, so we're going to do f at 4. Anywhere I see that x value, which is only one of them, I'm going to replace it with a 4. So So I get 1/3 times 4 minus 1 squared. Inside the parentheses first, 4 minus 1 is 3 squared. We get 1/3, 3 squared is 9 exponents, and now we can do our multiplication. 1/3 of 9, or 9 divided by 3, gives me 3. So I know f at 4 is equal to 3, and as a coordinate pair, that'd be at 4, 3. Alright, so solution of a quadratic equation. We call them many different things, and we'll kind of discover why as we move along with talking more about quadratics. We talk about them as solutions. We talk about them as x-intercepts because that's where they cross the x-axis. We call them roots, and we call them zeros, okay? Those are our 4 names of things. Remember, make sure you have those. You will be tested on those. The number of solutions of a quadratic can vary, so it just depends. I can have no solution, so notice right here, I have a quadratic facing upwards. It's never going to touch this x-axis, so I'm never going to cross. And I could have the same thing as if I had a negative quadratic. There's a possibility where I have this gap. There's no way this is going to turn back and cross the x-axis, okay? The next one I have is I have one solution. That's if my vertex right here is right on the x-axis. I could have the same thing if I had something going downwards, right? -1. It's just my vertex, so it essentially what happens is it's coming up here, touches at that vertex, and then starts its way back down, okay? Or I could have 2 solutions like this picture on the far right, where my vertex is below the x-axis and it's going upwards, so it's going to cross twice. And same thing, if I have my vertex above the x-axis and my parabola is going down, that's going to also take me to having 2 solutions. Alright, so finding the solutions of a quadratic by graphing. So it says find the roots of f of x equals x squared plus 4x minus 5. This is a calculator problem. I'll try to upload a video of how to do it on the calculator, but it's fairly simple. I'm going to show you how we're going to do this on my iPad calculator, and then it's fairly similar on the Inspire. And so if you'd like some extra help, I'll be able to help you with that. Okay, so I'm going to switch over to my Inspire calculator here. I'm going to graph. Actually, let's just start a new one. We're going to add a graph here. So my function was x squared plus 4x minus 5. Okay, so hit enter. So there's my quadratic. I'm looking for a 0. So just like when we found the maximum not too long ago, for you guys, you would hit the menu button, and then we're going to analyze the graph, and we are looking for a 0. So I'm going to just use that. Boom, there's one of my zeros at -5, 0. Perfect. But I want this second 0 as well. I'm going to bring it over here. Boom. 1, 0. So there are my 2 different spots, right? That's where it crosses the x-axis. Not too crazy difficult there. Okay, come back to our PowerPoint. So we found it we're at -5, 0. And at 1, 0. Notice in both of these that my y coordinate is a 0. Okay, so that's awesome. And that's because if we think about where my zeros are, they're right here on the x-axis. Well, my y, right, my y values, my y is always going to be 0 here. And so when I'm writing a solution or a root, my y values will always be 0, because that's the definition, right? That's what we're looking at there. Okay. So ways to find the solution of quadratics. We can find it by graphing. We can find it by factoring. We can find it by completing the square. We can use the quadratic formula. So we talked about these two today. We'll talk about the next two in the next couple classes. Alright, so solving quadratics by factoring. So first we have to factor the quadratic, okay? So we set the y equal to 0. I have x-intercepts are where the y value is 0. Then we're going to utilize the zero product property. Utilize the zero product property. So that says if one or more items are being multiplied and equal to 0, at least one of those items must equal 0. Set each factor equal to 0 and then solve. So that's kind of my steps of how to do this. Let's look at how we do this. So this says find the solutions to the quadratics of y equals 2x squared plus 9x plus 10. And we're going to solve this by factoring. I'm going to use what's called the tabular method to factor this. It's kind of this little boxy method. I just want to give you guys some more ways to factor. So in this first upper left hand box, we're going to put my 2x squared. Okay, and then in this this diagonal box, it needs to add to be that middle term, that 9x term, and in this bottom right, I'm going to have a 10. Okay, so I can fill in that 2x squared and that 10. The big thing I got to find right now is I have to find what's going to make up these two boxes right here, right? And it's going to depend on my factoring, okay? So what I have to do, the very first thing I'm going to do is I'm going to multiply by my coefficient of that x squared term and that 10. So I still have to do this this step. So 2 times 10 is 20. I'm going to come up with all my factorizations of 20. So that means 2 or more numbers multiplied together to be the third number. So in this case, I have 1 and 20. And I know that everything's positive because my b value is positive, okay? Because multiply to get 20, I either have to have both numbers negative or both numbers positive. So I have my positives here. So I have 1 and 20, 2 and 10, and 4 and 5. And they need to add up to 9, so I get that 4 and 5 right there. So I can add those in right up here. I can say 4x and 5x, and it doesn't matter which one goes where. And actually, let's clean that up. Wait. Oh, we're still going. I thought I'd stop the recording. Perfect. Okay. All right. I'm going to just clean that up a little bit. So I have 4x and 5x. Okay, so what we're going to do here is I'm going to take just this first column right here. I'm going to say, well, what can I divide out or factor out of this? And it's going to be an x, right? Nothing else. I don't have anything else in common. And I'm going to look at this next column. So, well, what can I factor out of here? And it's a 2, right? All right. Next, we're going to start going this way. So, well, let's make that one green. What can I factor of 2x squared? Well, I can take a 2x out of that, right? And really what I'm asking myself is, I already have this x right here. So x multiplied what gives me 2x squared? Well, I need another 2x there. So 2x times x gives me 2x squared for that upper left. And then I can check it in this top right. My 2 up here, and then my 2x right here. 2 times 2x gives you 4x. So that's perfect. And then we do the same thing down here. So in the bottom left, I already have an x here. I need a plus 5. Okay, so I'm going to say, well, I need plus 5 because x times 5 gives me 5x. And then we can check it. Is 2 times 5, 5x, we're good there. Okay, so what I find is that I get y equals x plus 2 times 2x plus 5. So to solve this, I know this happens when y is 0. So 0 equals x plus 2 times 2x plus 5. And then we look at that zero product property, meaning that if one of them is 0, and I'm multiplying anything else, I multiply it by a 0. So I'm going to set this up as two equations. 0 equals x plus 2, and 0 equals 2x plus 5. We just solve for each of these. We subtract 2 from both sides. I get x equals negative 2. On the right, I'm going to subtract 5 from both sides. Divide by 2. So I'm not finished. I need to write these as coordinate pairs. Negative 2, 0, and negative 5 halves, 0. There's my solution. Okay, I want you guys to try this. Find the by factoring. Once again, I'm going to use this tabular method. Go a little bit quicker this time. I know I get an x squared there. I know that this has to add up to be 3x, and this is going to be my negative 10. So I might multiply by my coefficients of the two terms I do know. So in this case, it's a 1 and a negative 10. And I get negative 10. So I know that one number has to be positive, one number has to be negative, and my bigger of the two is positive, so when I combine, it remains positive. So I have negative 1 and a positive 10, negative 2 and a positive 5, and that's it. So which one's going to add up or combine to be positive 3? I get right there. So I'm going to say I'm going to put negative 2x here and a 5x right there. Now when I take that first, that left column, I can take an x out, the right column. Let's take just a positive 5 out. Now when I'm looking for this left corner, I already have this x. I need one more x there. And then 5 times x gives me 5x. We're solid there. And then down to the bottom right, or let's go bottom left, x times what gives me a negative 2x. I just need a negative 2. And then 5 times negative 2 gives me negative 10, so we're solid. So my factors are x plus 5. We're going to set this equal to 0, and x minus 2. Then I set each one to 0. I'm going to subtract 5 from both sides. Get negative 5 equals x. I'm going to add 2 to both sides. And I get 2 equals x. Okay, that's all it is. Please practice and try these out. If you have any questions, please come and talk to me. Thanks.